Welcome to this explainer from the Foundry by Forge College. Hey, if you were with us for the last lesson on trust and governance in Web3, you know we laid down the rules of the road. We figured out who gets to vote, how decisions are made, all that good stuff. But here's the thing. Rules alone don't build a network. Today, we're talking about the paychecks, the actual economic incentives that get the digital building built. We're going to look under the hood at the exact mechanisms that make sure a decentralized system doesn't just look pretty on paper, but actually thrives and survives out there in the wild.
So think of me as your friendly neighborhood system architect today. We are unrolling the master schematic to see exactly how we engineer these Web3 networks to be self-sustaining. Here's our agenda. 1. From rules to rewards. 2. 3 dimensions of alignment. 3. Blueprint for decentralized file storage. 4. Sketching a token model. 5. Fixing common economic failures. And 6. Sustaining the Web3 ecosystem. Let's get to work. All right, section 1. From rules to rewards. This is the connective tissue of a network. Okay, let's dive into this.
To really wrap our heads around this, let's look at a pretty stark contrast. Over on the left side of our schematic, you've got your classic centralized value capture. You know the drill. A company builds a platform, they charge users a fee, and they use that revenue to pay their employees and, of course, enrich their shareholders. It's a standard corporate payroll. But over on the right side in Web3, we don't have a traditional payroll. We have decentralized ledgers. So instead of a boss handing out salaries every 2 weeks, these protocols use hard-coded rules and public payoffs to coordinate everyone. The value flows directly to the active participants, the folks actually providing the services, validating the transactions, and building the network.
But, whenever you're relying on the open internet to get stuff done, with literally no manager looking over anyone's shoulder, you kind of have to ask the obvious question. Why don't people just cheat? I mean, come on, it's human nature. If you leave a jar of digital cookies totally unattended on the internet, someone isn't just going to steal the cookies. They're going to steal the cookies, the jar, and the digital table they were sitting on. As system engineers, assuming everyone is highly opportunistic, that's not being cynical. That's literally step 1 of the design process. And that brings us to this absolutely crucial concept, incentive alignment. We have to design the embedded rules and the expected payoffs so that trying to pull a fast one, what game theorists politely call a rational deviation, becomes a remarkably costly mistake. We essentially have to rig the payoff matrix. We make it so that acting honestly, keeping your servers online and supporting the network is literally more profitable than trying to attack it. You align the self-interest of the individual directly with the survival of the network. Moving on to section 2. 3 dimensions of alignment, designing the payoff matrix. Let's see how we balance this out. So how do we actually build that matrix? We can't just toss tokens at people and cross our fingers. We have to carefully balance 3 specific dimensions. First up, we have actor-level payoffs. These are the direct rewards you get. It could be monetary, like block rewards. It could be governance influence, like voting weight, or even reputational capital. Second is mechanism observability. The beautiful thing here is that transparent blockchains largely solve this for us. We can publicly verify everyone's actions on-chain, no centralized referee required. But the third dimension, that's where it gets tricky. Time horizon design. See, we have to stretch out the rewards, because if we just hand over all the money on day 1, participants might just grab the bag and run. We need long-term vesting to keep them invested in the protocol's future. Section 3. Blueprint Decentralized File Storage. Let's unroll a real-world schematic and see this in action. Now, what's really interesting about this slide is how the economic connective tissue perfectly maps to each specific role in the network. Look at the first row. We have providers. They offer up their storage space. But to do so, they actually have to stake tokens, and in return, they earn a share of the fees. This encourages them to maintain high uptime. In the second row, we have clients. They pay those fees to get lower storage costs and reliable access to their data. And finally, in the third row, we have the stakers, or validators. They put down a deposit to constantly monitor the providers and ensure the data is actually there. It's this brilliant, perfectly balanced triangle of economic accountability where everyone keeps everyone else in check. Now, you probably caught that the mechanism for both the providers and the validators relies heavily on this idea of staking. If you're new to the term, staking is basically creating a verifiable economic bond. You lock up your own personal assets into the protocol. And here's the kicker. Those assets can be slashed, which means heavily penalized or even completely destroyed for misbehavior or server downtime.
When a provider has their own actual value locked up and on the line, attempting to cheat the network suddenly transforms from a clever little software hack into a massive, self-inflicted financial failure. Section 4. Sketching a token model. All right, it's your turn at the drafting table. Let's move through this and see how it builds. This is exactly the kind of practical thought exercise you tackle in our broader Forge College learning community. It's a 4-step workflow, and hey, don't worry, no advanced math required here, just solid structural logic. Step 1, clearly define the roles in your network and the exact behaviors you need them to do over and over again. Step 2, choose one on-chain lever for each role. Maybe it's a staking penalty, maybe it's a fee reward. Step 3, design the timing and the magnitude. Are you giving a small immediate reward or a massive delayed one? And step 4, anticipate how people will inevitably try to break your system and add mitigations to stop them in their tracks. Which brings us to Section 5, fixing common economic failures. What happens when our perfect blueprints meet unpredictable human nature? Well, to be blunt, without mitigations built in, our beautiful protocol is basically a bridge made out of wet spaghetti. Catastrophic engineering disasters are 100% guaranteed. Let's look at 3 big ones. First, token dumping. This is where early users get massive rewards and immediately sell them off, totally crashing the price. We mitigate this with long-term vesting schedules, dripping tokens out slowly over years. Second, Sybil attacks. This is where one person spins up 1,000 fake cheap accounts to hog all the rewards. We fix this by requiring minimum staking thresholds, making it way too expensive to fake a crowd. And third, governance capture, where a massive whale buys up all the voting power just to rewrite the rules in their favor. We counter that with stuff like quadratic voting, where each additional vote costs exponentially more to buy. It ensures raw wealth doesn't just equal absolute control. Section 6. Sustaining the Web3 ecosystem. Time to talk about long-term value accrual. So the crucial point is this. Strong short-term incentives, we're talking high yields, massive airdrops. They are fantastic for bootstrapping a brand new network and getting initial servers online. But long-term alignments are what actually preserve stewardship. Because if your tokens just constantly change hands like a giant game of hot potato, without any actual productive coordination happening underneath, the network's value just erodes away. The price signals become incredibly noisy, driven purely by speculation instead of actual utility. You absolutely need mechanisms that encourage participants to hold, stake, and genuinely use the token inside the ecosystem. Which leaves us with one final, pretty profound question to ask of any protocol blueprint you ever look at. Does this incentive design coordinate productive, real-world value? Or does it simply enable short-term speculative capture? Keep that question in the back of your mind every single time you evaluate a new Web3 project. It's a real game changer. Now, if you want to dive deeper into these mechanics, practice these workflows yourself, and learn way more about the technical and social constraints of Web3, I highly encourage you to check out forge.college. Thanks so much for joining me for this explainer, and keep building.